quadratic function, a function that can be written in the form y equals ax squared plus bx plus c. This is the standard form for a quadratic function. The graph of a quadratic function is a U-shaped curve called a parabola. And here's an example. So here's an example of two parabolas that have been graphed. The first one is y equals negative ax squared plus bx plus c. And the second one is ax squared plus bx plus c. The only two difference in the equations is the first one has a negative in front of the a. But when we look at the graphs, we see they're going different directions. The first one rises to a point we call a vertex and then falls. Since this vertex is the highest point on the graph, we call it a maximum. A parabola is symmetric, so we can draw an axis of symmetry or a line of symmetry through the vertex. In the second example, the graph falls to a point, the lowest point, the vertex, so since it's the lowest, we call it the minimum, and then it rises. Again, it's symmetric, so we can draw the axis of symmetry or the line of symmetry through the vertex. So here we have three examples. We need to determine whether it's a minimum or a maximum. We're going to name the vertex and write the equation for the axis of symmetry. So in the first example, the graph rises to this point, 0, 1, 2, 3, 0, 3, and then falls. Since it's the highest point, it's a maximum. And our line of symmetry goes through the vertex. So the line of symmetry is going to have the same value as the x, so it's going to be x equals 0. And in this instance, it happens to be the y-axis too. Next example, the graph falls to this point, 1, negative 1, and then rises. This is a minimum. It's the lowest point. And our axis of symmetry goes through that. The equation is the same as the x value, x equals 1. In our third example, the graph falls to a point, the vertex, negative 2, negative 3, and then rises. Since it's the lowest point, we call it a minimum, and we can draw the line of symmetry or axis of symmetry, and then we write the equation, Vx equals negative 2. So it has the same value as the vertex, as the x of the vertex. When we graph parabolas, we can also describe their domain and range. So the domain is the x values. What are the possible x values? Well, in this case, this can extend all the way to the left, negative infinity, all the way to the right, infinity. So it's all real numbers. And that's true for the second graph. The domains in both cases are all real numbers. In the first graph, it falls to a minimum, and then it rises. So the lowest, the range can be the y value is a negative 5. So since that's the lowest, all the other y values are greater than or equal to that negative 5. And in the second case, the vertex is the maximum, 0, 5. So 5 is the highest y value, so all the y values have less than or equal to that. So y is less than or equal to 5. So now we're going to graph a quadratic function that's in the standard form y equals ax squared plus bx plus c. We're going to use the example y equals x squared minus 6x plus 4. So the first thing we're going to do is identify a, b, and c. The coefficient a goes with x squared, b goes with x, and c is the constant. So in this example, a is 1, B is negative 6, and C is 4. Now that we've identified those, we can find the axis of symmetry, which is going to help us find our vertex. So the formula we need to remember is x equals negative b divided by 2a. So it's a negative b, so we write negative, and our b is a negative 6, so we write that in parentheses, negative 6, divided by 2 times a, which is 1. So that's 6 over 2, which is 3. So our axis of symmetry is x is equal to 3. So we know our x value for our vertex is 3 because the line of symmetry goes through the vertex. The question is, where's the vertex? What's the y value? So to do that, we just plug it back in. So we take 3 squared, which is 9, minus 6 times 3 is 18, plus 4, negative 9 plus 4 is negative 5. So my vertex is 3, negative 5. So if I were to plot that, it would be, there we go, right about there. Really good. And that's my vertex. So that's why we find the line of symmetry, because then that makes it easier to find the vertex. Another way we could have done that is, once I have figured out I have to calculate my line of symmetry, which is x equals 3, then I could plug the function into my calculator and then hit trace and then type in 3 for the x value, and that would go ahead and calculate the y, or my x, or my vertex. Now we're going to create a table and find any 2 other points on the graph. So we have our axis of symmetry is at 3. And our vertex is 3, negative 5. So now I'm going to just calculate 2 points on the graph. And so I'm going to choose for my x value 0, because that'll make the math easier. 0 squared minus 6 times 0 plus 4, that's going to give me a 4. And then I'll choose 1. 1 squared minus 6 plus 4 is 1, minus 6 minus 5 plus 4 is minus 1. And I could have also used my calculator. So go ahead and we're going to plot those points 0, 4, 1, 2, 3, 4, and then 1, negative 1. Now it says, finally reflect these 2 points, those 2 points across the axis of symmetry. So we found the axis of symmetry, which helped us find the vertex. And then from there we picked 2 points. Now to find 2 points on this side, since the line of symmetry is the axis of symmetry divides it in half, we can reflect the points over. So 1, 2, 3, 1, 2, 3. 1, 2, 1, 2. And then we can draw, then we can draw our parabola. I knew I shouldn't have tried that. Then we can draw our parabola. I'll stick to that. So you go ahead and try. So the first thing you do is you identify your A, B, and C. A is negative 1, B is 4, and C is 3. Then you find your axis of symmetry by plugging these values in for this formula. So x equals negative b over 2a, x is equal to 2. So our line of symmetry is x equals 2. To find my vertex, I put that in the calculator and traced and hit 2, and I got my vertex at 2, 7. or I could have just substituted 2 in the original equation. Now, create a table and find any 2 other points on the graph. So here I used -1 and got a -2, used 0 and got 3. I could have also looked at my table. I plotted -1, -2, and 0, 3, and then I reflected them, and then I drew my parabola. So comparing widths of parabolas, use the graphs below. What is the order from widest to narrowest of the graphs of the quadratic functions f of x is equal to -4x squared, f of x is equal to 1/4 x squared, and f of x equals x squared. So the first thing, if we wanted to match the graphs, they've already matched them for us. But since this is the only one with a negative in front of the x squared, we would know it's this graph, because with a negative, it's going to rise and then fall. So these would have a positive xa value. This is the parent graph, y equals x squared. This is 1/4 x squared. So when I multiply this by a fraction, if I start with this and then take 1/4 of that, it's going to make it fatter here. If I multiplied it by 4, it would make it more narrow. And since I multiplied by -4, it made it more narrow and it reflected it. So this coefficient with your x squared is going to tell you how narrow or wide your graph is and what direction it's pointing. So f of x is x squared is called the parent function. So that's the basic, what you're going to compare everything, whether it's wide or narrow, to. And fractions cause the parabola to get wider. And integers cause the parabola to get thinner.